Hi, this is Maury with XDynamics. Today I want to give you a brief summary of how lithium-ion polymer batteries work and why they're still the best batteries for drones. LiPos are different than typical cylindrical celled batteries. They have a polymer housing instead of metal, which makes them incredibly light. They can also be designed and constructed to almost any shape for precise application. Most batteries are electrochemical, which means they store electrical energy by way of a chemical medium. That stored chemical energy can then be easily reconverted into electrical energy. This charge and recharge process can be repeated many times. The basic configuration of most batteries consists of a cathode, anode, and electrolyte solution. The cathode and anode, the poles, are two different types of metals. The cathode is the positive terminal and the anode the negative. It's the electrolyte solution that conducts electricity. When the drone is powered on, the chemical reaction starts, causing electrons to flow from the anode to the cathode. This flow of electrons will continue until the metals in the battery are chemically neutralized, resulting in a dead battery. The voltage produced by this process is called the electrochemical potential. The power produced by the battery is dependent on the type of metal chosen for the reaction. If you were to make a battery, especially for drones, you would want the lightest materials available. You also need a material that's highly conductive. So why lithium? It just so happens that lithium is the absolute lightest solid on the periodic table and has the highest electrochemical potential. LiPos are sometimes called rocking chair batteries. When a lithium battery is discharged, the anode is electrochemically oxidized, and the lithium ions move into the electrolyte solution. During this process, electrons move through the external circuit and travel to the cathode. Then, the lithium ions travel across the electrolyte to account for the negative charge that is flowing into the cathode from the external circuit. This causes the lithium ions to be absorbed by the cathode. When we charge the battery, this is reversed. Standard lithium-ion cells use a liquid electrolyte solution that must be contained in a cylindrical container. What makes lithium-ion polymer battery packs different is that they use a gel-type polymer as the electrolyte medium instead of liquid. A polymer can take any shape and doesn't require the cylindrical enclosure. The entire space of the battery pack is full of energy. No wasted space, no added weight from any metal containers. In addition to high energy density, the discharge curve of lithium polymer batteries makes them perfect for drones. If you were to use nickel cadmium or nickel hydride batteries, the power and performance of drones would diminish substantially throughout the flight. With a LiPo-powered drone, you'll maintain near top power and performance throughout the entire flight. With LiPo batteries, there's also no memory effect. This happens when batteries are not fully discharged before being recharged and results in lower power and capacity over time. Not the case with LiPo batteries. For the Evolve 2, we have a 14.8 volt battery with 6,700 milliamps, resulting in 99.2 watt hours of power, just within the FAA guidelines for air travel. And this gives us flight times up to 30 minutes, even with a large Micro Four Thirds sensor. Thank you very much for your time today. We look forward to seeing you on our next feature video with the Evolve 2.